In 2.1, we are talking about frequency distributions, histograms, and other related topics. So first off, we have to talk about frequency tables. So a frequency table partitions data into classes or intervals of equal width and shows how many data values are in each class. The classes or intervals are constructed so that each data value falls into exactly one class. Now I'm going to go through all these different definitions and how to find things, but it's going to make much more sense once we actually get to our examples. So we're going to have what we call the lower class limit and upper class limit. The lower class limit is the lowest data value that can fit in a class, whereas the upper class limit is the highest that can fit in a class. Your class width is your difference between the lower class limit of one class and the lower class limit of the next class. If you want to find your class width, you take the biggest number in your data set minus the smallest number in your data set. Then you're going to divide it by however many classes there are. Your class frequency is the number of values corresponding to that class or that group. Midpoint is the center of each class. So you add the lower class limit plus the upper class limit and divide by 2. Your class boundaries are halfway points between the space between the upper limit of one class and the lower limit of the next. So to find those, we're going to add 0.5 to the upper, subtract 0.5 from the lower. The last definition is relative frequency, and that's your proportion of all the data values that fall into the class. So you're going to do class frequency divided by the total number of values. We're also going to look at histograms with these frequency tables. And a histogram is kind of like a bar graph. It's going to be there to show you the bars for each of the classes, and it is a way to visually organize your data. Now, as I go through these examples, if you need to, make sure you hit pause and rewind and see how I'm going through and doing these, because it might take you a while to figure out how to find each of these parts. So for example 1, I've got 20 numbers. We're going to use 4 classes. They tell you your class width is going to be equal to the biggest number minus the smallest number divided by your number of classes. That's that definition for class width. So I find the biggest number in my group. We're going to find the smallest number in our group, and we're going to subtract them. So 47 minus 2, and we're going to divide that by 4 because we have 4 classes. Now when I do that, we're going to get 11.25. But you can't have 11.25 numbers. You're always going to round up for your class width. So we're going to make that 12. That tells me there are 12 options for each of my groups here when I group them. So when you do your class limits, you start with the smallest number in your data values. 2 is my smallest. I need to make sure I have 12 numbers in this first row, or an option of 12 numbers. So you don't take 2 plus 12. Because if you do 2 plus 12, you're actually making 13 numbers that fall in that group. So we want 2, and then we're going to actually add 11 to it. Yes, your class width is 12, but we add 11 because the number 2 is already one of the numbers. We need to go up 11 more numbers. So 2 plus 11 gives me 13. You then move to the next highest number, 14. And I want to add 11 to 14, so I get 25. Now, if you're wondering, why am I adding 11 every time? What's this about 12? There are 12 numbers. So if you count out from 14 to 25, you are counting out 12 numbers. The class width is how many numbers are in each row. There are 12 there. So when I go to my next group, we are 26 to 37. And I got to move up a little bit. Then my last row is going to be 38 to 49. Yes, I know 49 is not listed in my numbers, but all of your class widths have to be 12. You cannot stop early. Every single one of those ranges has to be from the number to 12 past that, or sorry, 11 past that. Has to be 12 in that group. Now for your class boundaries, these are going to be 0.5s. So you want to be 0.5 to the left and to the right of 2 and 13. So it's going to be 1.5 to 13.5. And then it's going to go 13.5 to 25.5. 25.5 to 37.5. And 37.5 to 49.5. Now your frequency, that's how many numbers fit in that category. So right now you are looking at that list of 20 numbers. You are finding all the numbers that fall from 2 to 13. It can include 2, it can include 13. Now when you go through these, it might be better to use different colors as you mark off, just so you remember which ones you've marked off. So for instance, if I look at my list here, I know that we have 13, 7, 8 and 10, 3, 3, and 2. So if I count 1, 2, 3, 4, 5, 6, 7. There are 7 numbers in that group that fall into the first row. You're going to keep doing this for all of the other numbers. So you're going to look at numbers 14 through 25. If you go through and cross off numbers 14 through 25, you're going to see there are 8 of those up there. Again, cross them off. Make sure that you have 8. Now 26 to 37, cross off all the numbers 26 to 37. You should have crossed off 3 numbers when doing that. And then 38 to 49, cross off all the numbers from 38 to 49. You should have had 2 there. Now make sure that this frequency column, when you add them all together, you get the number of numbers that you have. So if I do 7 plus 8 plus 3 plus 2, I should get 20 because we had 20 numbers, so my frequency has to add up to however many numbers we have. Your midpoint. When you find your midpoint, you have to take the lowest of your class limits plus the highest of the class limits and divide by 2 every time. So we're going to take 2 plus 13 and divide it by 2. It is okay if you have a midpoint that is a decimal. So I should have 7.5. Now when you type that into your calculator, actually do 2 plus 13, hit enter, then hit divide by 2. So I've got 14 plus 25, divide by 2, 26 plus 37, divide by 2, 38 plus 49, divide by 2. So my midpoint should be 19.5, 31.5, and 43.5. Now the last one is your relative frequency. So for your relative frequency, what you're going to do is you're going to take your frequency and divide it by the total number of numbers. So we're going to take 7 and divide it by 20. Now when you divide these, you're going to get a decimal, round to 2 decimal places. So I divide those and get 0.35. You're going to do that for the whole group. So you're going to take 8 divided by 20. You're going to take 3 divided by 20. And you're going to take 2 divided by 20. So we've got 0.4, 0.15, 0.1. So this is going to be my frequency table. Now with that frequency table, we are now going to make what they call a histogram and a relative frequency histogram. So with our histograms, we are going to go through and we're going to look at our data and we're going to make our bars for each one of our datas. So since I had 4 rows there, we are going to have 4 bars, not 6 bars, sorry. We're going to have 4 bars for the table. Now, when you make your histogram and relative frequency, I'm going to split this here so I keep my boundaries. So we are going to be making a bar graph. I'm going to just call it my histogram. And we need to make sure we label everything from our parts that we know. On your y-axis, so over here, this is going to be your frequencies. So in my table, my frequencies were 7, 8, 3, and 2. So I need to make sure I start at 1, 2, 3, 4, 5, 6, 7, 8. And I go up to my highest number. Now, when we go through and do the x-axis, that's going to be your class boundaries. Now, we always have to jump here. When we use those 2 hash marks, we have to jump to go to my 1.5 because we're not going up by the same amount from 0 to 1.5 and then 1.5 to our 13.5. Since those are different distances, we use 2 hash marks there to mark a jump from 0 to 1.5. So I've got 13.5, I've got 25.5, 37.5, and 49.5. So you're going to put all of your class boundaries on the x-axis. Now what we're going to do is make these bars that match to our different groups. The 1.5 to 13.5 group had a frequency of 7. So we're going to go up to 7 here. And we're going to make a bar graph. Then we're going to go to 13.5 to 25.5, and that was 8. So you're going to just extend it a little and go down. Then 25.5 to 37.5, there were 3 there. And the last one is 37.5 to 49.5, and there were 2 for that group. So that would be my histogram because the frequency is on the y-axis, or the one going up and down, and your boundaries are on your x-axis, the ones going left to right. Usually we label our x-axis with whatever we're talking about in the problem. Here is just 20 numbers I gave you, but in the next one, we actually talk about a situation, so we're going to label our x-axis there based on what we are finding or what we're using in our table. Now, the relative frequency histogram is very similar to this, but we are going to use the relative frequency column. So not the frequency column, but the relative frequency column now. So it's almost pretty much the same thing, but look at your relative frequency. The relative frequency goes from 0.1 as the lowest to 0.4 as the highest. So I can go 0.1, 0.2, 0.3, 0.4. And again, this is our relative frequency. Sometimes it's hard to squeeze in there, so you can abbreviate. Now, the x is going to be the exact same numbers. So we're going to start with 1.5. Then we go to 13.5, 25.5, 37.5, and 49.5. So your boundaries are always going to be your x there. Now first group, we have from 1.5 to 13.5, it was 0.35 for the relative frequency. And again, all of these numbers are listed in your table. So if you look at the relative frequency column, that's how I'm getting my numbers here. In my next group, we go up to 0.4. And the next one we have 0.15. And then our last one's 0.1. So you can see these are very similar in their pictures, just one is frequency and one is relative frequency. Okay, with this you try one, it's going to be a little bit longer one for you to do on your own, but I want you to go through and see if you can fill out your frequency table, do your histogram and your relative frequency histogram all on your own. Then you can go back through and play and see how I got my numbers, or to see what numbers I have. That way we see what you can do on your own, and then you can compare with what I have. So pause the video now. Hopefully you have already gone through these, and you have the numbers that I will be putting up on the board, so hopefully we can compare our numbers together. Here we have an irate customer called Dollar Day Mail Order Company 25 times during the last 2 weeks to see why his order had not arrived. Each time he called, he recorded the length of time he was put on hold before being allowed to talk to a customer service representative. Create a frequency table with 5 classes. So here's all of our numbers. Remember, you find the biggest number, smallest number. In my group here, my smallest is 1, my biggest is 15. So you should have done 15 minus 1. Divided by the number of classes, so 5. So when I subtract and divide, we get 2.8. But remember, we can't have 2.8, we have to have 3. That means there are 3 numbers in your group. So I start at 1, I don't do 1 plus 3, we do 1 plus 2. Because 1, 2, 3 is 3 numbers in your group. So I need to go 4 to 6, 7 to 9. I got to move a little bit. We're going to go 10 to 12, 13 to 15. Now for your class boundaries, these are the 0.5s. So you're going 0.5 to the left, 0.5 to the right. So again, you have your 0.5s there, 1.5 to the left, 0.5 to the right. For your frequency, you had to go through and count them. Your first group, you should have 2. Second group is 10. Third is 9. Fourth is 3. Last one has 1. That's a total of 25, which is what we need because we should have 25 numbers there. For your midpoint, you take 1 plus 3, divide it by 2, and you should have gotten 2. 4 plus 6 gives you 5, gives you 8, 11, and 14. Your relative frequency then is your frequency divided by the total. We write this as a decimal. So those should be your relative frequencies then. Now for your histogram and your relative frequency histogram, you're going to take all of those numbers and we're going to put it into 2 graphs. So you should have titles that go with these. You're looking at the length of time on hold, so you should have a title with that. I will tell you right now, if you do not put titles on your tests and quizzes, you will not get all the points. So make sure you put titles on everything. So for our histogram, remember, we have the frequency with this one. Now for our frequency, it goes from 1 to 10. And then we've got our class boundary. So we make our break. I've got 0.5 to 3.5 to 6.5, 9.5, 12.5, 15.5. Now sometimes I cannot space these out very well, but they should be the exact same spacing for each one. You should have the same bar widths for each one. Now for my label, it's going to be time on hold, and it was in minutes. So if we go to your first group there were 2. Next group there are 10. Next group we've got 9. Then we've got 3. And then we have 1. Now we're going to do the same thing with our relative frequency. And again, length. So now this is going to be the relative frequency. And relative frequency starts at 0.04 and goes to 0.4. Let's see. So we're going to do 0.1, 2, 0.4. Make your break. And my 0.5, 3.5, 6.5, 9.5, 12.5, 15.5. So for the first one, it should be 0.08. Next one is 0.4. Then we've got 0.36, 0.12, and then we've got 0.04. So there is our other histogram. Don't forget your label for the x-axis also. So time on hold and minutes. You do not label the bottom as class boundaries, but as what goes along with your story problem, whatever problem that you have.